So this week we are talking healthcare, and not just healthcare. We're talking the how to turn the operations of, in this case, a hospital, in fact, several hospitals, into a production line that with a level of automation that assembles an automotive production line or an Amazon warehouse. And if that sounds crazy, with all of our personal experience of the healthcare system, no matter what country you're in, then I would say keep listening. My guest today is Dr. Burak Bardak. He's the CTO of a company based in Turkey. They operate globally called Borda, Borda Technologies. And he's got a deep IoT background, but they've taken IoT for healthcare and have turned it into a system which resembles, and you'll hear us talk about this, the world's biggest Sims game, where you simulate, it's not simulating, you're showing the real-time collaboration between assets in the healthcare, the staff in a hospital and people, i.e. the patients, and then putting agentic AI on top to define the processes, optimize the processes, change the processes, and give comparative KPIs across different hospitals within a country or within a healthcare group. It's a very interesting story. It really links IoT with AI, which is a big subject right now, and gives some great examples of what agentic AI can do. Without further ado, let's get going with my interview with Burak Bardak, who's the CTO of Borda Technologies. Enjoy. So Burak, good morning and welcome to the IoT Leaders Podcast.
Good morning, Ig.
Great. Now, this is a very interesting podcast because healthcare is a really important area, and we're going to get into the whole healthcare vertical. But before we do that, you've also got a very deep and long experience in the field. And one of the themes of the IoT Leaders podcast, especially the recent ones we've been doing, is the increasingly their IoT and AI. And I think this one in particular really is a blend of those two. So to start us off, can you just give me an overview of your background and the different areas you've worked in before you arrived at Borda Technologies as the CTO?
Yeah, sure. Thanks for inviting me again. I'm originally from Cyprus. Completed my undergraduate studies in electronics and communications in Istanbul, Turkey. I worked with AI for wireless communication during these studies, and this was back in 2007, actually. Later that, I moved to England for my master's in computer engineering. Again, I focused on AI algorithms for image reconstruction and enhancement. Back in 2008, my path led me to location technologies, which is both indoor and outdoor positioning and navigation, which was my PhD research was focused on. I did my PhD in London at University of Westminster, worked on a Galileo project called Insight Project. It was a collaboration between 4 different universities and industry. And my research focused on optimization, system integration, and then for my postgraduate studies as a postdoc, I worked on edge processors for cameras, developed parallel processing algorithms and compiler implementations to run AI at the edge, which is within the cameras, up to 600 core processors. Everything is within very low latency. And after nearly a decade, I transitioned into the private sector, working in highly regulated industries like banking, finance, healthcare, and payment systems.
That's very relevant, very impressive. Essentially, that's 18 years of experience in the areas, and from a time well before it was called IoT, it was machine learning, but also 600 processors in a camera. I believe from when we spoke originally, that was in military settings. We can't go into that, but that's incredible power. Edge processing, that's a great example of edge processing and AI image enhancement. And I know that that was in the biological field. You're looking at cells.
I worked on image reconstruction for microscopes. We use different phase information to enhance the image. And in order to do that, we train the AI in the background, which is an In the old days, we called them the neural networks. Now the name is
neural. That's right. The self-healing neural networks. Is now that Microsoft used to brand them.
And we enhance the images, get the 3D, we convert the 2D images to 3D ones with the AI, with the help of them. And then basically these things build up, small things, they build up, and it came the AI that
we know today.
And everyone's
changing weekly, as we find on this podcast. So you're now at Border Technologies, and you're based in Turkey. And most people who listen to this, I think I'm right, probably won't know anything about Border Technologies, although we do have the listeners, viewers in 95 countries. So there will be some people in Turkey who know all about you and the other countries in which you operate. But for everybody else, can you just give me a high-level overview of Border Technologies and what they do and its relation to the background, the deep background you've got in IoT and AI?
About 6 years ago, I joined Border Technology. I lead work on next generation IoT location technologies. In simpler terms, we build the next generation technology for indoor tracking. So we track entities in enclosed environments, indoor and outdoor environment actually. And we built the technology to be able to do this in a very high precise and low latency way. So basically, we can achieve up to 10 centimeter precision with battery powered tags.
Okay, so let's go into the tech a bit. We're going to talk a lot about business processes and get into Agentic. But on our journey, let's start with the bottom rung of the tech. Asset tracking indoor and outdoor, specific capabilities, which is very relevant to your background of being able to identify an asset within 10 centimeters, I think you said, which is not very much at all. That's pretty industry leading. And it uses, is that BLE technology from a sensor that attached to
so it's multi-technology. We use ultra-wideband, we use BLE, RSI-based, and we use BLE angle of arrival. So for the ultra-wideband, you can achieve to the 10 centimeters. With the BLE angle of arrival, you can achieve to the sub-meter level accuracy, which is 40, 50 centimeters. And then with the RSI, you get a kind of a zone level accuracy.
So you're using some form of triangulation. We're going to talk. So if it was in a hospital, you're putting sensors, battery-powered sensors on devices using triangulation to identify them. And the battery life of one of these sensors?
So we call them tags, actually. And these tags, they have 5 years of battery life. Usually it's around 2 to 5 years, depending on the usage. And our gateways, which we call them locators, and they are used to calculate the angle of the transmitted signal from the tags. They are called locators. And they power through the Ethernet, power over Ethernet. We install these on ceiling. And then we have these tags. This is a sample staff tag, which has 5 years of battery life. We can track the staffs or persons who wants to be tracked, and for various reasons can be tracked less than 2 level, let's say.
Again, to help people unpack this, you held something up there that looked like a credit card, but most people are probably listening. The taxonomy here is assets, people, and patients. Now in the healthcare environment, a hospital, for example. And we'll talk about a case study. But if we so first of all, the assets are the tags that get physically attached to assets.
Yes. So the asset tags are very small tags that we have. Again, I'm showing it, but it's a very small 3 by 5 centimeter tag, which has 5 years of battery life, and we can track the asset's location along with some inertial with these tags. They also have some inertial sensors, so it can sense the vibrations, they can sense the temperature, they can sense the movement of the asset.
Movement. So you build up a picture of all the assets in a hospital, and we've had a couple of healthcare examples on the pod. Tracking assets in hospitals is a major issue because people tend to pick them up. If it's a trolley or something, they roll it down a corridor, they take it somewhere else, and nobody ever knows where it is. So tracking the assets. Now the that looked like for those listening, you were holding up something that looked like, I would say, like a very thin domino. That was about the size of it. Domino piece. Then you said about the staff. Now, the staff was the credit card one. So we're tracking assets and triangulation. The staff are the nurses and the doctors, I assume, and there'd be some
Nurses, doctors,
healthcare workers.
yeah,
It's the credit card size device. And I think you mentioned the word safety when you
yeah,
so what's the use case for the staff? And then from there we'll get into the patients.
sure. So basically, unfortunately, there can be attacks on healthcare workers in hospitals. And our job is to prevent these attacks and for dress purposes, staff dress. We call our product called dress prevention. So whenever a healthcare worker is being attacked or someone is basically the tension is increasing in that particular situation, they double click or maybe it can be programmed that, or they long press on our staff tag. And this basically triggers an alarm in the background with the exact position of that particular staff. And we can even connect to CCTV cameras and get some screenshots and send them to security.
Right.
And then security will know which staff is being under attack, by whom, and where.
Okay.
And then security there to prevent this attack being to the healthcare work.
Okay, so primary use is security of staff, and it is a big thing. A&E, all over the world, it's a big thing. There's a lot of people who've drunk a lot who tend to end up in A&E with mental health issues. But of course, a side effect, of course, is you're also getting the location of the healthcare worker as well. So now you've got the location of the assets, you've got the location and whether they're moving or not, or vibration. You've got a location of all the healthcare workers and their identity, so you know where they are. Now let's look at the third aspect in this triumvirate, which is patients. So talk me through what happens if I'm going to a hospital in Ankara in Turkey, patient. How does this system track me? What happens when I check in as a patient?
Okay. After you check in as a patient, basically we get the admission information through the integration through the EHR to our system, and the nurse knows which patient needs to be tagged, and they go next to the patient and they take the patient. Taking the patient means something like a smartwatch, a very small tag. I will show it again, but
a wrist tag or something. Oh, there you go.
something like a wrist tag.
Yeah.
And with the wristbands, which is our tags are used. They attach this wristband to the hand of the patient, and we can start tracking the patient's location.
So again, for those of you not on video, because Barak has been holding up several devices, so not on video.
Yeah.
What I would say is, if you've been to a Coldplay concert, you've been issued with a wristband that changes color. It looks like that.
It's smaller though. It's a bit lighter.
I'm not using the video for the Kiss cam. That's another story. But it's smaller than that. But essentially, what we've got here is, if you think of the picture, we know the location of all the assets and they're moving and what assets they are. We know the location of all the healthcare staff and who they are. And we know who the patients are. And I know in Turkey and across the Middle East, and I'm very jealous as someone who I've operated out of the Middle East, and I don't know this, but I'm very jealous as someone who's in the UK. You also have the systems, the data, that the patient's healthcare records can be integrated as well from the GPs, the doctors, nationally and across the region. So that really helps, because then you've got all the patient's history in the data. Yeah. So what you've got is like this model with the patient history, and then above it, you've got assets, staff, and you've got patients. And now you've got the data. And again, in my mind, it's like a big Sims game. It's a very complicated Sims game because it's a hospital and everything's moving. The staff are moving, the assets are moving, the patients are moving, and a lot of information about everything. Okay, so that's the basics.
And obviously, it's a very big Sims game, and this 7/24 operation, the operation doesn't stop. And you have to be on the move all the time, and you have to collect all the information that you can get from the sensors, from the network, or from the HR, and feed in one big system and start working on your magic to optimize it, make it more efficient, track turnaround times, make them faster, more efficient. You have to manage your capacity. So it goes on. It's like a very big system, very complex system, and you need all of the information you can get to feed in that model that you created and start on the optimization.
So you're visually encourage people to think of it like a stack of bricks. You've got the bottom level, you got the basic data from patients' health records, the GPs around Turkey, or even visitors. Are you fortunate to end up in this hospital? And you've got the assets. You've got the big sim game of the assets, the people, and the staff and the patients. And now you're collecting a lot of KPIs, which is what you just talked about. You're collecting, I would imagine, tens of, if not hundreds of thousands, I mean, over time, millions of data points, KPIs, into a system, which I guess comes to now what border technologies do. And it's going to lead us into the AI piece.
Yeah.
Because now you have a solution now for not just reporting the KPIs, but actually looking at the processes and the process optimization. Is that right?
Yeah, that's 100% correct, actually. So we, for obvious reasons, we track staff and patient and the assets. And asset is a very big part of the operation inside the hospital. Because obviously medical devices, they are very expensive. And it's very hard for hospital management to measure the usage of these assets. And they somehow invest and procure more assets than they need because they don't have any way to measure the utilization of these assets. That means our system provides them the visibility to reorganize, move the assets to the right places, and that with doing that, they can reduce the asset, they can increase asset utilization, they can reduce the investment they need to make for the assets for the hospital. And basically, they overpurchase by 20, 30% because they don't know where their equipment is, they don't know how are being used, they don't know how, if they are maintained, if they are up and running, if they are calibrated. So our system basically solves that problems and they can reduce the investment they have put in by 30%.
30%. Just basic information like
Findings.
sometimes it's the simplest. It's the simple stuff which has the biggest payment ROI. We did a podcast recently on which is also IoT and AI with the guy who runs IoT for an AI for Volvo 140 factory, and he's tracking millions of components. But he said one of the biggest paybacks is when they make a truck and they put it out in the field. They're all white initially before they get painted, and they do that in stages, and they have to call them back into the factory for the next stage of assembly. And they can't actually, they don't know which truck is which. So they lose trucks. They lose trucks in huge fields because they're all white and they have a team of people who run around zapping barcodes on windshields to find a particular truck that needs a certain extra added to it because of the configuration. But this is a similar concept is you're finding portable x-ray machines, ultrasounds, important bits of
IV pumps, patient monitors, wheelchairs, beds, whatever that hospital use for within the hospital, we track them.
And you say it's down the corridor in the room on the left.
Yes.
Now, that's KPIs. Now, what's interesting, certainly when I spoke to you previously, is that a lot of systems that we see stop at the KPI. They say, here's an asset tracking system. Look at the data, look at the KPIs. You can get an efficiency by finding assets quicker. But what I know you're doing is you have a series of AI tools. I'd like you to, because you're now taking it up the next layer of the stack, which is the agentic, using the KPIs, using the data because the AI is only as good as the data you feed it. So you're collecting, step one, collect all the data from everything time. And then you're feeding it up into an LLM and you're using agentic AI. So let's break that down for the listeners in terms of what.
It's a very interesting subject.
Yeah, it is. Yeah.
So we are building agents in the background. So we do have the system to collect the data, as you said, and which is the most precise data you can get from as location wise and the sensor wise. We obviously have the ability to collect them. We collect them, we store them, and we feed them to an AI agents in the background, such as proactive asset management. It's an AI agent in the background that monitors common usage in real time. Instead of staffs are going to check manually, this AI agent can check and predict when devices are underutilized and recommend reallocation. This will basically increase the utilization and prevent new purchases. And also operational workload as well. Okay. Obviously, on top of that, every asset that within the healthcare sector, actually within any industry, almost requires annual maintenance or maybe weekly or monthly maintenance, calibration, cleaning, and storage. And these are all operational costs. And these are a couple of $100 per device per year, let's say. And this is basically, this can be prevented by using an AI agent in the background, which is offloading the operational workload from staff to the AI agents that works with real data. Again, workflow optimization we do have in the background. We basically follow the workflows. It can be patient or staff movements. It can be interaction between staff and asset, or it can be interaction between staff and patient, or asset and a patient, which is quite common. We can tell which asset is used for which patient. So this interaction is the data in this interaction is very rich, actually. We can extract the information if this asset needs to be maintained, needs to be cleaned, disinfected before used to another patient. We can put in a work order for cleaning to the biomedical team. You can prevent using this particular asset if it is not calibrated, it's not good for use. You can prevent that. And you can flag all the bottlenecks in the background. You can put in beds. If a certain patient is waiting for a room to be cleaned, you can basically, in the background, you can optimize the workflow. You can put in a cleaning order and you can reduce the wait time. Everything is in the data, actually. And we are building agents.
Excuse me, because you're saying some really interesting stuff, and I just want to make sure, because most people aren't doing this. So you're living it and breathing it. So I want to really make sure people are understanding this, because the agentic AI, which is fed by the data, and that's a series of, as you said, workflow optimization capabilities that run in the background. And so the idea of a patient has finished with a procedure and needs to, I don't know, be put in a room for a period of time, but the room's not clean. And the person who normally would be wheeling the patient on the trolley down the corridor doesn't know the room's not clean, gets to the room's not clean. So then we've got to find another room. People end up in corridors. Lots of examples. I can think of a personal example. Occasionally, I've ended up in A&E, probably when I've done something stupid or something's happened to me. And I'm thinking, why does it take 7 hours? And I'm talking from a UK perspective, but I think it's pretty bad over the world. And if you actually look at why it takes 7 hours, and sometimes it takes 17 hours, most of that time is you're waiting for the next step in the process. You're sitting on a plastic chair in a room with a terrible TV and a coffee machine that doesn't work. And you're waiting for you get triaged very quickly. That's quick. And this is going to be great. And then you wait and you try and work out who's ahead of you in the line. And then you see the doctor. Then the doctor wants you to see somebody else. And then they do some tests. And then they have to wait for the results. And then at the end, they say, okay, this is what it is. You just go back to your chair because your medication, we need to get your medications. Don't leave until you get your medications. But then you wait again and you wait again.
Yeah.
And so there's all these process inefficiencies. And what you're describing, and that makes up the bulk of the 7 hours. I think it probably makes
Yeah.
6 of the 7 hours. What you're saying is that I think, and keep me honest, is that as a result of collecting the data, you're not only getting the KPIs, but what the agents are doing, because they're reacting real time and they are changing. Agents are dynamic. Then it's not like SAP workflow or any of these ERP systems where you define the processes and the processes never change. What you're saying is that the data is dynamic. The agents, they could be a procurement agent, behavior agent, a support agent to take support from reactive to proactive. Let's do an update because we know it's going to need an update, and that'll all be automated. Lots of different agents. These agents are actually then able to map out the dynamic, again, keep me honest here, but the dynamic picture of the process for this operation. This procedure could be a cataract operation. It could be what happens in A&E. It could be a kidney investigation, a kidney operation. So you're now getting optimized process information for what a hospital really does, which is execute collaboratively with people and assets and patients across a series of processes. And so you've now got this, the Sims game is now much more than assets. It's a series of processes that are interacting with a big dashboard showing efficiencies.
It's actually a series of very complex processes, and AI agents learn from this process and they interact between each other. They update. An asset agent can update the workflow agent, so the workflow agent can create another action. So everything becomes, actually, obviously it will become like that. Everything will be connected to each other. Everything will talk to each other. And then the adaptive AI will solve the problems where you need an actual human controlling the actual healthcare worker. It can be a nurse or a doctor, needs to be.
It frees them up
solve
to
the
do what
problem.
they should be doing as opposed to the admin. It gets rid of the admin and some of the bureaucracy. And if I'm a general manager or a manager of a hospital, this dashboard is incredibly important to me because it can save me money, as you point out. Basic save 30%. But it also enhances the patient experience.
And the quality of the healthcare service that you are getting as a patient.
Yes.
That's very important. Wait time, the quality of the asset that is being used with you is well maintained, is up to date, is calibrated. Imagine an IV pump which is not calibrated, and instead of pushing 1 liter per hour, it should push you 3 milliliters per hour. And it's a disaster. And
so they get a better healthcare experience.
Yes.
It's ultimately what it's all about. But the other question I got is, there's more than what you have. A lot of hospitals as customers in Turkey, for example, Canada, the US. I know there are areas that
in Canada, Middle East, and Turkey, obviously, is most of our customers are in, but we do have some customers in Europe as well. It's all around the world, actually.
All around.
And
if I'm where I was going, Burke, is if I'm a CEO of a hospital, or the CFO or whatever, management team of the hospital, I can see the data on my hospital, and I get the AI agents should allow the specialists to focus on what they were really trained for, which is to give healthcare. It gives a better patient experience, gives better healthcare, more importantly, and it saves a lot of money, eliminates waste, etc., etc. Can I actually see how well I'm doing in my hospital versus other hospitals?
Yes, you can compare them. We do have customers that big hospital groups, they own multiple hospitals, they track the processes with our system, and we can actually compare 2 different hospital buildings managed by 2 different management teams. And we can compare their processes, their asset utilization rates, even we can compare their performance on the operations, OR rooms, the OR rooms utilization rate. We can compare the length of the duration of the operations for
Different hospitals.
different hospitals, different doctors for the same procedure for different patients. Obviously, we can compare what's the verdict there, why it took 2 times longer than the other one, and those stuff. It usually is an operational failure. The operation didn't start on time because the disinfection team didn't arrive, they couldn't clean it, or maybe the asset was missing, they waited for the asset. Since we track the asset, we know the asset has been delayed and they waited that time for the particular asset. So, yes.
Yeah, so there's even an HR advantage. If you run 6 hospitals, you're part of a hospital group, you can look at you can do performance measurement across the hospital. So it's a very interesting area. And as I said, AI is something which, in our experience, it is just, people are just realizing what it actually is. It's not ChatGPT.
Only that, yeah.
But people think it is. Actually, because we do have a technical audience, not exclusively, but a lot. I mentioned at the beginning of the pod, you're using you're not just betting everything on one model, or can you just maybe describe at a high level which model?
Yeah, obviously healthcare is a highly regulated environment. You can just get the information about staff location or assets calibration data and put in a public LLM. Actually, you have compliance, GDPR compliance in the background. So we do have our own data sets. We do have our own LLM in the background, and we use some public LLM as well. OpenAI is one of the favorite that we have. But for interactions with the end users, which can be a little bit more challenging because nurse can be from a different country, they can use different words. We use public LLMs, but the interactions that require the data access to that particular hospital's data, we use on-prem or maybe in cloud, a private LLMs account, private agents.
Okay.
Yeah.
A series of different ones, which is consistent. People say it's not one AI, you use different tools for different purposes. Yeah. And of course, the humans are still interacting, but they're looking at the data, they're interpreting it, they're checking it with their knowledge.
And they have the ability to correct the workflow, actually. So we allow them to give feedback to their particular AI agent so we can improve it.
So it can be improved, which is how they do the accelerated learning.
Yes.
So the robots are not yet in control. But let's finish, because I think it's a very interesting area. And as you said it very briefly, as you said, this is healthcare, but actually there's been a lot of people listening to this saying that's very applicable to the industry I'm in. But where do you think, because going back to your beginning, you've been in research, you've been 18 years in what we now know as AI. You've done a lot of different things. You've got very technical. I should have mentioned you, because you're a PhD, you're a doctor in the field. Where is it going? Because it seems like you're defining the whole operationalization of, in this case, the healthcare it's almost like it's catching up with what would be normal on a very advanced manufacturing line, say in automotive or an Amazon warehouse. Would that be right?
Yeah, actually, yes. It can be an automation production line or Amazon warehouse. Let's say if a tool or part goes missing in a production line, the production stops. It's the same as in a warehouse. And if you don't know where the items are, you end up searching them. And everything is delayed, your processing time gets very bad. And the hospital faces the same problem, actually. Instead of lost packages or delayed cars, it's patients. The care is obtuse. The waiting gets longer. You end up waiting in ER 6 hours for a small procedure. RTLS and the IoT brings the same precision and efficiency into healthcare, and you make sure that the staff and patients are always in the right place at the right time, in the right order of workflows.
And as you were speaking, I could actually make the case that it's more complex than a production line, because you're taking the philosophy of the just-in-time production, production line, which is well known in manufacturing, or the robots working in the factory for Amazon, with the humans just looking at screens and being told what to do next. But you're taking that, you don't have members of the public wandering around the production line of your factory. Yeah, you don't have people wandering around picking their own boxes off the shelf at the Amazon warehouse. You've got thousands, tens of thousands of patients. It's the patient component. It's the what I call the triumvirate.
And the other thing is also you have the time component. With the wait time goes long, the patient's situation can change. That increase the risk of workflows to be disturbed or has to be changed. And you need something in the background that adapts to the workflows, adapt to the changing situations, because the problem that you are trying to solve keeps changing, and you have to keep track and update yourself. You can just say, okay, this is the predefined workflow, we have to follow it. No, the situation can change.
And then the agent modifies, and it can actually say, okay, based on new data I've got, now this is the new workflow process. Okay. Listen, let's finish. We could talk for a long time about this. Let's finish here. I want to come back to I talked about the Coldplay analogy. I think you told me you've seen Coldplay recently.
Yes, a couple of weeks ago.
Okay. I've seen them as well. It was an amazing concert. The patient gets the wrist bracelet. Now, when you leave the Coldplay concert, as you come down the stairs at Wembley, or I assume it was Wembley, there's people there collecting them. Please hand them back. Is it the same system for you? Do you collect them back off the patients? And what percentage of patients hand them in?
So basically, the process is there. If a patient is going to be discharged, the nurse should go there and take the bracelet out and discharge the patient. If they don't do that, they can't be discharged. If there's an alarm that goes up, because we also monitor the patient for their own safety.
Yeah, like taking the the arm. Yeah.
Maybe the patient should be leaving that particular room. Maybe it's an infectious patient that has to be quarantined. We also track those, and they can't take out their bracelets. They have to cut them, and when they cut them, we monitor the bracelets condition, and we get a warning in the background. They are trying to tamper the tag. So we don't lose the tags. Obviously, like maybe 1 or 2% is being lost or being stolen, but we don't use the tags, because losing tags means losing the patient. We don't lose the patients as well. We make sure the tags are attached to the patient from admission to discharge.
Okay. And they're taken off and they're thrown away, and because they need to be sanitized. So listen, I think we should stop it here. It's a very interesting area. Just to recap, your company is called Borda, BORDA, Technologies. And I know you've got on your website quite a few case studies of hospitals, healthcare institutions that are using the system. And I also know that the opportunity in this particular area is huge. Healthcare I think, is the single thing every government spends. Healthcare and defense, but in is where they put most of the money, and it's just accelerating as we get older and more demand for treatments. But I do believe also it's not healthcare specific. The concept of what we talked about of the IoT, the data, in your words, the assets, the staff, and the people or the customers is actually generic across many industries, and the operationalization of a huge complex entity like a hospital and turning operationalizing through technology a hospital where the staff are following the instructions, like the Amazon warehouse where on the screen it says, do this next, is a very interesting idea and has huge ROI. I want to thank you, Bert, for being on the pod. I think it's a particularly interesting one. And for anyone listening, please visit Borda, BORDA, Borda Technologies, and you get a wealth of information there in the case studies. And as I say, we do have listeners all around the world. And I think every country where we have listeners wants to solve problems like this. Thanks again for being on. Good to talk.
Thanks, Nick, for inviting me.
It
was very lovely talking to you.
Yeah.
And hopefully the listeners will get the same.
I hope so. And
feeling.
one day, and I know we don't want to talk about the NHS in the UK. Okay, we can't go there because then I'll really get frustrated. But one day, let me just say, one day I really hope we have a British case study that actually talks about this.
Yeah, we are looking for that actually. Hopefully we'll do. Very good use case with NHS in the
Yeah,
future.
because boy, do we need it. Boy,
Yeah.
do we need it. Anyway, thank you, Bora. Really appreciate it. And thanks for being my guest on the IoT Leaders podcast.
Thank you. Thank you for your time.